Today we're going to learn how to build a couple of types of basic oracles on EigenLayer. To do so, we're diving into Waves. Waves is short for WASM or WebAssembly AVS. Waves is a platform that lets developers easily build and run services or AVSs on EigenLayer with less complexity than building from scratch. So what is an AVS? AVS stands for Autonomous Verifiable Service. You can think of AVSs as smart services that process data off-chain but still provide verifiable results on-chain. Another way to think about AVSs in EigenLayer is similar to how we think about AWS as a platform that hosts services like S3, EC2, and DynamoDB. EigenLayer is a platform for building verifiable services like oracles, coprocessors, zk-TLS, verifiable AI, data availability, and a handful of other verticals of services. AVSs enable developers to build rich and expressive applications without being bound by any blockchain virtual machine. Unlike smart contract programming environments, you can do complex computation, interact with arbitrary APIs, databases, data sources, and LLMs, and anything else that you can do in a standard web server and still provide verifiable results on-chain. Waves takes care of the heavy lifting of building an AVS, like infrastructure and operator coordination, so you can focus on writing the core logic of your service. Here's how Waves works. You write your core service in Rust. Waves compiles it into WebAssembly or WASM, a lightweight and high-performance executable. Operators then run your service off-chain, verify the results, and submit them back on-chain. This means you get the speed and flexibility of off-chain computation with the trust and security of a blockchain. So why use Waves? Here are some key benefits. Number one, you can focus on business logic and forget about managing infrastructure. Waves handles all of that for you. 2, composable services. You can chain multiple components together to create complex workflows. Number 3, it's lightweight and fast. Since Waves uses WASM instead of a bulky Docker container, services start up quickly and run efficiently. Next, it has multi-chain support, so your service can interact with multiple blockchains seamlessly. And then finally, dynamic updates. If you need to tweak your service, you can just upload a new component, so there's no downtime or operator coordination. So how does Waves work? Let's walk through the basic components of a Waves service. First are triggers. These are events that start your service. For example, when a smart contract emits an event on-chain, operators detect it and execute your service logic. Number 2, service components. This is where your logic is executed. Your code, written in Rust, is compiled into WASM and runs in a secure sandbox environment called WASI, short for WebAssembly System Interface. And then finally, there's the submission logic. Once the service runs, results are signed by operators and submitted back to the blockchain for verification. Here's an example. Imagine you're building a price oracle. A trigger event sends price data to your service component, which processes it off-chain. Operators verify the service and submit it on-chain to use in other applications. So what are some use cases for Waves? First, oracles. You can create oracles that bring trusted off-chain data on-chain, for example, weather data, stock prices, sports scores, or election results. Cross-chain bridges. You can securely transfer assets between blockchains by triggering verifiable off-chain computation. Next, there is a whole design space within ZK. You can deploy ZK verifiers or provers as lightweight components for privacy-focused apps. And finally, decentralized AI. You can build AI agents that make verifiable decisions without relying on centralized servers. These are just a few examples, but again, you can do anything that you'd like to do off-chain and verify it on-chain, so the design space is quite large. Now that we understand what Waves is, let's build something with it. First, we're going to start off with the price oracle that comes out of the box with the new Waves project. Then we'll vibe code a new oracle for bringing sports scores on-chain, similar to how a prediction market might function. So let's get started writing some code. What I want to do is go to the Waves documentation to where we can say create your own project. And obviously, before you get here, you might want to go to the system setup and make sure that you have both Docker as well as Foundry installed on your machine. Once you do so, we can run forge init, and this is going to initialize a new project using their boilerplate. And what I can call this is Waves Sports Oracle. And then once this is created, we can go ahead and open this up in our text editor. And we'll dive into the code in just a moment. But for now, let's look at the documentation to see the rest of the setup. So I'm going to run through this and go down here to make setup, where we have a make file with a few different commands that we can run. After we run make setup, we're going to go back to the docs and we're going to go here to build and test components. The two commands that we're going to be running are make WASI build and make WASI execute, or make WASI exec. So here I can run make WASI build, and this will go ahead and build out the project. And now that the build is complete, I can run make WASI exec. And here we can kind of see the result of this price oracle, where we get a price feedback for BTC. So what we're going to do now is dive into the code and kind of understand a little bit about how this is going, or what's going on here. Now, if we look at the code, there's quite a bit going on, but like a lot of starter projects, or just really reference architectures, there's quite a bit of boilerplate, and there's really only two main files that we truly need to focus on to get started understanding what's going on. The first is going to be components /eth price oracle /src /lib.rus or lib.rs. And then there's like basically two functions here that we're going to really need to dive into. And then the second file is going to be the make file. The make file just has all of the different commands that are set along with any hard-coded variables. So checking out lib.rs, we have this main function here called run, and then we also have this get price feed function. And the run function essentially is calling this get price feed. And here you can kind of see that we have some arguments that are being passed in. And really the one thing that we want to get is the ID for the, I would say, token that we want to get the price for. So the price feed oracle is essentially taking in a token ID, and then we use that ID to kind of get the price. And you go down here, you can kind of see that this get price feed function is essentially just calling the CoinMarketCap API and passing in the ID. Now, if we go to the make file here and we look for WASI exec, we can kind of see the command that's being passed on here. And the one thing that we have hard-coded right now is the CoinMarketCap ID. And this is number 1 for Bitcoin. So if we go here and we want to change this to, say, number 2, we can run this command again and then get a different price back. So here we see the symbol as BTC. Now we see the symbol as LTC. All right. So we kind of understand the basic stuff going on in this price oracle. What we want to do is we want to vibe code this to be a sports oracle so we can build something like a prediction market, for example. So the way that we're going to do that is we're going to do two things. First of all, I'm going to provide the prompt that we're going to use. And this prompt is going to essentially copy a lot of the logic that we have in the ETH price oracle. And we're going to replace the ETH price oracle with this sports radar API that can then pass in a game ID. And then once we pass in the game ID, we can get the results of that game. And for our example, we're going to be working with the NCAA data. So what I can do is I'm going to go to my terminal and I'm going to just say Claude. And this is basically Claude code. You can install it by running npm install-g. I forgot exactly, but it's something like Claude code. You can Google it and find the command. And once you have it installed, you can just run Claude from your terminal. Okay, cool. So we have Claude open, and we're going to now just run this prompt. And we're going to walk through to kind of understand what's going on here. I'm going to tell Claude that I want to create a similar oracle to the ETH price oracle at component/ETH price oracle, but I want to use the Sport Radar API. I want to set and reference the Sport Radar API key from the make file. So this way we kind of hard code the API key there. I then pass in the request parameters so that the project understands how to format the URL and what type of headers to pass in. So we're calling like api.sportradar.com. We're passing in the game ID and we're passing in the API key. Next, I also describe what I want my execute command to look like. And basically, I want it to be calling the WASM sports score oracle. And I want to pass in two values. Number 1, the game ID, and then number 2, the sports radar API key. And then I also provide it with the basic command that I want to be able to run myself. So I don't want to have to pass in the API key every time. I just want to pass in the game ID, because the API key is going to already be hard-coded in the make file. And then finally, I give an example of the response data. So Claude and my project kind of understands the schema of this data that's coming back. And I say I only want to return the home team, the away team, the home score, the away score, and the status values. So this is a pretty, nice long prompt, probably, especially with this data here, making it much longer. But I can go here to where we have raw. I can copy this, and I'm going to now open my terminal. I'm just going to paste it right here. And then I'm going to hit enter, and we're going to try to walk through all of these different prompts from Claude Code. All right, so first it's going to ask to create the folder. We're going to say yes. Next, it's going to create cargo.toml. Next, it's going to create trigger.rs. Next, it's going to create our sports oracle version of lib.rs. Now, this is our main logic of our new component, so we're going to definitely dive into that and check it out in just a moment. We're going to create bindings.rs. We're going to modify the make file to set up our Sport Radar API key. We're going to edit the make file to add our new execute command, scores-exec. We're going to update the README to show how this works. Another update to the README. All right, and it looks like it's made all of the modifications. So the next thing we want to do is to go ahead and test this out. So what we want to do is we want to set the Sport Radar API key in our make file. So here we have the Sport Radar API key setting. And what I can do is I can go to Sport Radar here. I can go to the console where I've set everything up for the NCAA API key, and I can go ahead and copy this to the clipboard. And I will go ahead and paste this here. All right, so we've set the API key. The next thing I want to do is run make build. So I'll go ahead and split this up. We'll run make build. And then finally, let's go ahead and test this out by calling make scores exec and passing in a game ID. So what you can do on this Sport Radar API is you can go to the daily schedule and put in like a date, and it'll give you like all the games. And the game ID I got is from the NCAA like semifinals and Final Four. This is going to be Duke versus Houston. So if I go here to my terminal and I put in this game ID and we hit enter, we should test this out and see if it works. All right, boom, it looks like it worked. We got the result back. Duke Blue Devils, Houston Cougars, home score 67, away score 70. So what we've done is vibe coded a brand new component, and it only took us a couple of minutes. I'm pretty pumped and excited about how you can build and write code in this fashion these days. I've been doing a lot with it, and I would like to kind of do even more with it. So this is really cool to me. Now, if we go to our new folder and components, we can go to our lib.rs, and we see we have a similar kind of layout where we have this run function, and then we have this get game scores function. And we see that we have our Sport Radar API. It's literally just written all this for us, and it just works perfectly. I think it's incredible. So I think that's kind of it for this example. What I'm going to do is I'm going to push this code up to GitHub. I'm going to link to the prompt. I'm going to link to everything we talked about. And I will say a call to action. If you want to build cool stuff on EigenLayer, definitely reach out to us. Check out all the different platforms like Waves that are out there that really kind of lower the barrier to entry to building. And I'm excited and looking forward to see what you build in the future. Thanks for watching.